Hi everyone. Today we're going to learn about the directional derivatives, and I think it's one of the most easiest and the basic concept of unit vector, and it is one of the most important too. So without any further ado, let's just begin this. So directional derivative basically is del, which is partial differentiation, del phi by del s is equals to a cap into gradient of phi. This is the formula of partial derivatives, and we are going to use this one in almost all the questions in our textbook. All the questions of directional derivative, this formula is going to use. So let's just see how we're going to solve this one. So this is the question: find the directional derivative of phi equals to this in the direction of 3 I cap minus 4 j cap plus 2 k cap at point this 2 minus 1 3. So before solving any of the question, I highly recommend you all guys to please write the formula, which is del phi by del s is equals to a cap into gradient of phi. So this is the way in how we are going to find the directional derivatives, and only two things which we need to find, which is a cap and gradient phi. So for a cap we're going to have a into modulus of a, and the value of a is in the direction of vector, in the direction that is the value of a. Okay, so let's just write the value of a, which is 3 I cap minus 4 j cap plus 2 k cap upon modulus of a, which will be 3 square plus minus 4 square plus 2 square. So the value will finally become, this is 3, 9, 16 and 4, it is going to be root over 29. So this is the value of a cap. We already got the value of a cap, so now we only want the gradient of phi. This is also one of the simplest thing, gradient of phi. Now we're going to write this. For gradient of phi, one thing which we need to know is that del by del x I cap plus del by del y j cap plus del by del z k cap is equals to this thing, this phi thing, gradient of phi, which is 3x square yz. We're going to write this thing, 3x square yz minus 4y square z cube, 4y square z cube. So this is how we are going to find the gradient of that. Nothing much is in it, but just we have to partially differentiate x, and I think you guys know how to partially differentiate. But if you don't know, and if you're like me, I'm just kidding, if you don't know, you just have to take y and z as constant in case of different partial differentiation with x. So let me just tell you how it's gonna do. Let's just try with this one. When we partially differentiate del by del x with this thing, it will be 6x and yz as constant. There is no x, so it is 0. So let's just write it I cap. Plus when we do it y, it will be, with y it will be 3x square z, which is constant, minus 4 to the 8 y z cube into that, and same with the z, it will be 3x square y minus 4 8 12 y square z to the power 3. So that is the value of gradient of phi. So we have both the value, gradient of phi and the a cap, so we just have to put the values now. So for putting the values, we know that the del phi by del s by del phi by del s, I'm really sorry for that one, del phi by del s, which is directional derivatives, is a cap into gradient of phi. Just put the value of a cap here, which is 3i cap minus 4j cap plus 2k cap. 3i cap minus 4j cap plus 2k cap upon root over 29 multiplication by this thing over at the upper side, which is 3xyz I cap plus 3x square z minus 8yz cube j cap plus, oh my god, the canvas is a little bit smaller for that question, but anyways, it's a very simple thing and I know you guys will understand this in a bit. So now what we have to do is that we have to multiply I with I, j with j and k with k, I with I. So this into this, it will become 6, 8, 6, 12, 18, 18 x, y, z, z. At the same time, minus 4, it is minus 12x square z plus 8, 16, 24, 32, 32 y z power 3. We are very near our solution, just one multiplication we have to do more, which is 2 into that shit. 2 into that shit will be 6x square y minus 24 y square z cube. So that's what it is, nothing much about it, and don't forget to write root over 29. So that is our last thing is needed to do. When we go back to the question state that in the direction of this, in the direction vector this, at the point this, at the point this is a thing. So we have to put in the x, y, z, we have to put in x we have to put 2, y minus 1, at z we have to put 3. So 2 minus 1, 3. Let's just write here 2 minus 1, 3. We have to put the values here. So I guess it's a very simple calculation here, but still I'm going to tell you guys how you guys should going to do that thing. So let's just do it. 18 into x, which is 2, into minus 1 into 3, that is a thing, minus 12 into x squared, which is into 4 into z, which is 3, and 32 into value of y is minus 1 and value of z is 3 and it is 3 cube, and all those things are still there, plus 6 into 2 into 4 into minus 1 minus 24 into 1 into 3 cube, and don't forget the whole to the power is root 29. So let's just solve this thing in calculator. You guys can solve this in scientific calculator if you guys are engineer or studying any technical stuff. I'm going to solve this in a calculator, so let me just, okay, so the final value is minus 1356 upon root over of 29. Yeah, that's my answer, and that's how you guys should solve the question. So basically in directional derivatives, only thing, as I also mentioned earlier, only thing which you have to remember is this formula. Yeah, this formula for directional derivatives, which is del phi by del s equals to a cap into gradient of a. Just remember that, and for a I already told you just that thing, for gradient that thing. That's it from my side. I hope you guys like my tutorial for the first time, and thank you so much for watching, and don't forget to share this with your friends who want to study more and all those things. You guys know what to do, man. I don't really have to tell you. Thank you so much for watching.